Welcome to part 5 of the Module 9 review. We're going to pick it up at number 24 right now. So we have 3 times 4x plus 1 is less than 6 minus 5 times 4x minus 3. So here we need to distribute 3 in here is going to give us 12x plus 3 in here gives us 3 is less than 6. Distribute the negative 5 in, negative 20x. Distribute the 5 in, plus 15. Combine like terms, so 12x plus 3, less than, negative 20x plus 21. I'm going to move my x's to the left, so add 20 x's. And then that means I'm moving the numbers to the right, so subtract 3. Kind of do this simultaneously. So you get 32x, cancellation, less than cancellation, 18 divided by 32. And we get x is less than, and it looks like we could probably cancel a 2 in each of these. So 2 in there would be 9, 2 in here would be 16. So x is less than 9/16. So we're just solving it. So that's what we can write for that one. Looking at the next one, where we have 1/3 x minus 3 is greater than 1/9 6x minus 5. So I'm going to clear the fractions, that is, get rid of the fractions, multiply both sides by 9. So if we do that, 3 goes into 9 3 times. So we still need to distribute this 3 in here. So I'll say 3 times x is 3x, and 3 times negative 3 is minus 9. Here the 9's cancel, giving us the 1, so the 1 distributes in here, 6x, and the minus 5. So I'm going to get my x's to the right now to keep them positive, so minus 3x. Minus 3x, and then get my numbers to the left, so add 5, these cancel, so you get negative 4 is greater than 3x, divide by 3, you get negative 4/3 is greater than x, which is the same thing as x is less than negative 4/3. This looks better to me than that, whatever. I mean, we could put this in set notation like that, we could put this in interval notation, we could graph it, but we're just solving these, so we'll go with that. So the next one we have is, let me get up there, right there. So we have 19 minus parentheses 2x plus 5 is less than or equal to 2 times x minus 5 plus 2. So once again, this is classically, we're going to distribute. The trick here is that this negative right here is really the negative 1. So we have our 19, but this negative distributes in here to negative 2x, distributes in here to get our negative 5, less than or equal to. 2 distributes here and here, so 2x minus 10 plus 2. Once again, combine like terms, so negative 2x, or 19 minus 5 is positive 14, less than or equal to 2x. Combine like terms, minus 8. Get our x's on one side, so I guess it doesn't really matter which side we move them to. Subtract 2x, subtract 2x. So then we're going to have to subtract 14 and subtract 14. So 2x minus 2x is negative 4x. 14's go away, less than or equal to. 2x's cancel. This is going to be negative 22. Divide by negative 4. So now we divided by a negative, so we want to flip the direction of that sign, and that gives us x is greater than positive. Negative divided by negative is a positive, then we can get the 2 out of here, give us 11, 2 out of here too. So x is greater than or equal to 11 halves. Or I guess you could say 5.5 or whatever, fractions or decimals. As long as it's not an approximation, like 1/3 is 0.3, that's bad, but 1/2 is 0.5, I'm good with that. So. Okay, moving on to the next one. Now the next ones we have some solve and graph. So the first one we have is 9x plus 7 is greater than or equal to 34, and 9x plus 7 is less than or equal to 70. Okay, so subtract 7 from both sides here. So it goes 9x is, or 7's cancel, is greater than or equal to 27 divided by 9. We get x is greater than or equal to 3. So if we're thinking about this, x is greater than or equal to 3. That's 3. Greater than or equal to, we're shading that way. But because we have an and, we're looking for the overlap. So here when we subtract 7, we get 9x is less than or equal to 63. Divide by 9, and we get x is less than or equal to 9. So point of interest 9, because we have less than or equal to, put solid dot in. Shade this way. Because we're looking for where the two things overlap, we're looking at that. So an interval, 3 to 9, that would be the interval. Or we could write this as 3 is less than or equal to x, which is less than or equal to 9. So solutions and graphs right there. Okay, moving on to the next one, we have a little solving graph again. So this one, we have negative 20, just negative 20 is less than or equal to 8x minus 4, and 2x plus 7 is less than or equal to 11. So here, add 4 to both sides. So we get negative 16 is greater than or equal to 8x divided by 8. We get negative 2 is less than or equal to x, which is the same thing as x is greater than or equal to negative 2. So two ways of saying the same thing. X is greater than or equal to negative 2. Solid dot at negative 2, shading to the right. Once again, because we have an and, we're looking for the overlap between these two graphs. That's going to be our solution set. So here, subtract 7. 2x is less than 4. Divide by 2 and divide by 2. X is less than 2. Okay, so x is less than 2. So right here, when we have x is greater than or equal to negative 2 and x is less than 2, x is less than 2 is this, but it's really not even including that point right there. And it's going to the left. Excuse me. Oh my gosh. So, when we look at this, we're looking for the overlap of those two pieces right there. So, sorry about that. We have x is less than or equal to 2, not negative 2. So here is negative, like positive 2. X is less than that. That is what we're looking for right there. So we want to make sure that if that's at negative 2, that's a positive 2, we mark it as such. So because we're looking for and, we're looking for the overlap of this. Now, we're including this 2 because we have the solid dot, the negative 2 that is. So we start our interval at negative 2 and it goes all the way up to 2. So this is the interval notation. This is the graph where this is the overlap. Let's see, where this is the overlap piece. Going to that circle, to that dot. And then if we wanted to write this in set notation, we'd have negative 2 is less than or equal to x, which is less than 2. So that's the way we can think about that. Okay. So let's just do a couple more of these, and that'll be good for this part. Now, the next one here, we've got a couple compound inequalities. We got 20 is less than 5x, which is less than or equal to 40. So recall when we have these compound inequalities, these are really ands. But unless we have to graph them, it doesn't really matter. So here, if we divide everything by 5, we get 4 is less than or equal to x, which is less than or equal to 8. So 4 is less than x, which is less than or equal to 8. That's a perfectly valid solution. This would also give us the interval from 4 to 8. Not including 4 because we don't have the equals here, but including 8 because we do have the equals here. So parenthesis and then the square and bracket. So the next one here, we have 8 is less than or equal to 2t plus 4, which is less than or equal to 18. So we're trying to isolate this t here in the middle and get 1t. So first thing we need to do is get rid of the 4. So we have 4 is less than or equal to 2t, which is less than or equal to 14. Divide everything by 2. And we get 2 is less than or equal to t, which is less than or equal to 7. So this is a perfectly valid solution. If we want to put this in interval notation, starts at 2, goes to 7. We're including both of those pieces because we have the less than or equal and less than or equal to. So that's that one. So 31, we have, let's look at this. Negative 5 is less than 3x minus 12 over 4, which is less than or equal to negative 1. So first thing we want to do is get rid of the fraction and multiply everything by 4. So we multiply this by 4, multiply this by 4, multiply this by 4. That's a perfectly valid move because we're multiplying each of the pieces by 4. So it gives us negative 20. Now this 4 cancels with that, and what carries down is just our 3x minus 12, and that's less than or equal to negative 4. Next thing we need to do is get rid of the 12, so add 12 to each of these pieces. So this gives us negative 8 is less than 3x, cancellation, which is less than or equal to 8. Then divide everything by 3, and we get negative 8 thirds is less than x, which is less than or equal to 8 thirds. So we could write this in as that, or we could use the interval notation to solve that. Either one is totally fine. Parenthesis negative 8 thirds, 8 thirds square in bracket, because we want to include that one. So that's that. And then we'll just wrap up these compound inequalities, and then we'll move to OR, I guess, in the next video. So last compound inequality here, we have, yikes, negative 1/2 is less than 1/10 x minus 3, which is less than or equal to 1/2. So once again, I'm going to multiply everything by the lowest common denominator, and notice 3 is 3 over 1. So here I'm going to multiply everything by 10. So if I multiply this by 10, this by 10, this by 10, and this by 10, we're good. So 2 goes into 10 5 times. So 5 times our negative 1's negative 5. 10's cancel, so we get x. Here 1 goes into 10 10 times, so 10 times negative 3 is negative 30. And finally 2 goes into 10 5 times, so less than or equal to 5. Now add 30 to everything, and we get positive 25 is less than x, cancellation, which is less than or equal to 35. So this is a perfectly valid set notation, or we could say 25 to 30, not including our 25, including our 30. So that's what we're looking at. So see you next time for the OR. Then we'll do a little bit of graphing, and that's it.